Let f of x equal the square root of x and g of x equal the square root of 2 minus x. We'd like to find each of these compositions and the domains for each of those. Starting with f composed with g, that is f of g of x that we're looking for. So that's f of the square root of 2 minus x. And now I can take that and plug it into my f function. So this is the square root of the square root of 2 minus x. Now, the square root of the square root, that is simply the fourth root. The way you can easily see that is know that a square root is an exponent of 1/2. So this is 2 minus x to the 1/2, and then that whole thing to the 1/2. And by our exponent laws, something with an exponent on it and that raised to an exponent, you multiply those two exponents. So 1/2 times 1/2, which is 1/4. Now, as far as domain goes, this function here is an even-numbered root. And for even-numbered roots, we are not allowed to have negatives inside of those roots. So 2 minus x must be greater than or equal to 0. So getting x by itself, x then would have to be less than or equal to 2. And so our domain is, in interval notation, negative infinity to 2. For g composed with f, this is g of f of x. So starting with f of x is the square root of x. And now I'm doing g of that. And g of something is the square root of 2 minus that. So we're going to have the square root of 2 minus the square root of x. Now, as far as simplification, there's really nothing we can do here because we have a square root, but then it's being subtracted from something underneath the square root. And there's really not an easy way to combine or to, say, simplify a square root of a sum or a difference. So we'll go ahead and leave it in this form, but then we need our domain. And for the domain, there's two things going on here. First of all, we have this x that we're doing the square root of. So of course, we know x must be greater than or equal to 0 because we can't take the square root of a negative. But then this whole thing underneath that outside square root, that also has to be greater than or equal to 0. So 2 minus the square root of x must also be greater than or equal to 0. So solving that, we have that the square root of x must be less than or equal to 2. In other words, x is going to have to be less than or equal to 4. Okay? And we already have the other side of that, which of course is that x has to be greater than or equal to 0. So our domain then is everything between 0 and 4. So our domain in interval notation is 0 to 4 as a closed interval. For f composed with f, this is f of x. So first doing the inner f of x, that's the square root of x. But then I need to take that square root of x and plug it in to the function f, which takes another square root. So this is the square root of the square root of x. And again, just like up here, now we've got a square root of a square root. That's just the fourth root, or x to the 1/4. And for our domain, this is very straightforward. Of course, we're doing an even-numbered root, so that thing must be greater than or equal to 0. So 0 to infinity. And finally, g composed with g is g of x. Doing this inner g first, that is the square root of 2 minus x. And now for this g, this is going to take the input and put it right there. So I've got the square root of 2 minus my input. So the square root of 2 minus my input, which is the square root of 2 minus x. Okay, now for my domain for this, again, I can't simplify because I have a square root of a difference. But to get my domain here, I've got two things I'm taking the square root of. First of all, this 2 minus x. So I know that 2 minus x must be greater than or equal to 0. But similarly, I've got this square root out here. So that whole thing underneath the square root, okay, 2 minus the square root of 2 minus x, that also has to be greater than or equal to 0. So for this first condition, okay, that gives me that x has to be less than or equal to 2. This second one, if we rearrange this, we get that the square root of 2 minus x has to be less than or equal to 4. Now, if I square both sides, I get 2 minus x is less than or equal to 16. Now, you have to be careful here because the only reason I can just square both sides and not worry about, negative values here is that I already know that 2 minus x has to be greater than or equal to 0. Okay, now I can get x by itself, okay, and I'm going to get that x is greater than or equal to negative 14. So now I've got my conditions. I've got x is going to be between negative 14 and 2. And so my domain, I've got negative 14 to 2.